This room can charge your phone the moment you walk in. Disney Research has successfully turned a room into a wireless charging station. Quasistatic Cavity Resonance is a method that induces electrical currents in an enclosed metallic structure. Power generated and amplified outside the room is picked up by a coil receiver inside the room, then transmitted to discrete capacitors inside a copper pole. The induced currents flow through the pole, ceiling, walls, and floor, generating an electromagnetic field. 10 devices were powered by the room simultaneously in this experiment. Researchers conducted the study according to federal safety guidelines and believe this method should cause no harm to the human brain or body. Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews. Here are other stories about wireless charging technology. Israeli company wants to build electric roads that can charge buses and cars. Imagine if you could charge your electric car or bus simply by driving. That is the vision of Israeli company Electrode. Electrode has designed a system that charges electric vehicles by embedding energy transfer coils in the road. As a vehicle such as a bus travels over the coils, its battery is charged wirelessly. Electrode claims it can lay 2 kilometers of energy transfer coils in a day. Road is dug up by one machine. The coils are laid. Then another machine buries the coils under bitumen. Roadside equipment helps to monitor electricity usage. Electrode hopes to begin testing the system with a public bus in Tel Aviv. Aerospace firm files patent for electricity generating window shades. BE Aerospace has filed a patent for airplane window shades that are equipped with solar panels. The solar cells integrated into the window shades harness energy from the sun and turn it into power passengers can charge their electronic devices with. The company claims these new devices would only weigh slightly more than ordinary window shades and generate more energy than the extra fuel required to carry them. These devices would allow airlines to save money, conserve fuel, and reduce CO2 emissions. Modern planes equipped with traditional power points or USB outlets that are powered by the plane's electrical system require long lengths of wiring that end up being costly. BE Aerospace added that the solar window shade is easy for airline technicians to install on current aircraft and requires no change to the rest of a cabin's components.
Wearable energy generator powered by urine. Researchers at the University of West England have invented a pair of socks that use urine to fuel a generator that can power a wireless transmitter. The urine-powered footwear design was inspired by the simple cardiovascular system of fish. Soft tubes under the heels pump urine when a person is walking, circulating the urine over microbial fuel cells embedded in the socks. The microbial fuel cells contain bacteria that consume organic waste. The fuel cells convert energy produced by microbial growth into electricity. The electricity generated by the socks can power a wireless transmitter that sends a signal to a computer. The system comes with a container that can store up to 648 milliliters of urine. According to a press release published by the University of West England's website, this technology can use any organic waste to produce electricity. It also opens up the possibility to use waste to power portable and wearable devices.
Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews.
Solar-powered roads could power the entire US. Idaho-based Solar Roadways is hoping to build solar-powered roads that will not only provide power, but will also create digital driving services that can be remotely controlled. Solar Roadways says if installed nationwide in the US, their roads could provide more renewable energy than the entire energy the country uses. Solar-powered roads by Solar Roadways are comprised of hexagonally shaped panels that consist of 4 layers. A base layer of recyclable materials that is placed on the ground. A support structure with embedded circuitry, LED lights that collect sunlight and convert it into electricity, and finally a top layer of reinforced glass with traction support for vehicles. The panels can support trucks weighing up to 250,000 pounds or 115,000 kilograms, and the lights can be remotely controlled to provide guidance to drivers or to reallocate spaces in a parking lot. Electric vehicles would be able to use mutual induction technology to charge while driving. The panels also contain heating elements connected to the electricity grid that can melt snow and ice that forms on them. An attached cable corridor helps store and treat stormwater while also providing a place to store power and data cables. The cost of the solar panels can be covered primarily through the generation of electricity, which can also power connected homes and businesses. Solar Roadways estimates there is about 31,000 square miles or 80,000 square kilometers of usable road surfaces in the US that could be converted into solar-powered roads. Solar Roadways received a contract from the Federal Highway Administration to build the prototype in 2009. Now they are hoping for $1 million in funding in order to begin mass production of the road.